you doing? It's MrDoTheMath here, and today we're going to talk about special right triangles. Say it with me. Special right triangles. All right, so special right triangles, like I told you in math, there's several ways to solve every problem, right? There's several ways. And when we go to right triangles, it's no different, right? And so we have two different situations that we have with right triangles that we're going to talk about. Again, out the back, the main way to solve for the sides of right triangles, you use Pythagorean Theorem, right? What's Pythagorean Theorem again?
A squared
Plus b squared
equals c squared.
equals c squared. C squared being a hypotenuse every time, right? Now, with special right triangles though, it's almost like a shortcut-ish type thing, right? It's a shortcut to like solving for the sides of particular triangles, right? And so the first one is called a 45, 90 degree triangle. Right. So here's the backstory about 45, 90 degree triangles. Last semester we kind of talked about triangles and we talked about specific triangles. If this is 45 degrees and this is 45 degrees, what's the relationship of those adjacent sides to the 45 degrees? Say it louder. They're not equilateral, but they're going to be congruent to each other. Right? Y'all see that?
Yep.
Because this is 45 degrees and that's 45 degrees, the lengths of those adjacent sides are going to be equal as well. So that would make this what kind of a triangle? Say it. Isosceles. It's an isosceles, right? Isosceles means you got two congruent sides, right? So a 45, 90 degree triangle is also called an isosceles. So I can't spell isosceles.
I showed it.
Sign it out.
Isosceles. Isosceles right triangle, right? Iso. We just call it an iso right triangle, right? So we won't even deal with the isosceles part, right? It's an iso right triangle. Okay. Now, in solving for the sides of an isosceles right triangle, this is what happens. These sides are equal to each other. So that means these sides would be x. They would always be the same. And the hypotenuse is going to be x times the square root of 2 every time. Okay? It'll be x times the square root of 2. Okay? And now if we were to put numbers there, let's put some numbers there so you can see what I'm saying. If, let's do, if this is isosceles, right? If they say this is 45 and this is 45, even though they don't look isosceles, and they said this was 8. If this was 8, we can find the rest of these right triangles, right? If this is 8, that means this is how big? 8. By the rule, x and x, they're the same, right? And then this would be what?
8.
Square root of 2.
A root 2, right? Now, let me prove it to you. If we did Pythagorean Theorem to figure this out, this would be 8 squared plus 8 squared, right? 8 squared plus 8 squared is 64 plus 64. 64 plus 64 is what?
128.
128, right? The square root of 128 is going to be what? Who has the special calculator? 128. Like if you break it down, let's do it. Right? 128. What can you divide from here? Let's go ahead and start with 2. Right? 2 what? 264. Ocho, right? The 2 and 64, 8 and 8, right? So that means that's going to be 8 square root of 2. 8 square root of 2. Y'all see that?
Yep.
Everybody see that? Yep. Alright, cool. So like, that's how it works. Alright, now, what happens if they give it to you, like, let's get a more challenging. Okay, yeah. Oh, that's not hard.
That's hard.
Yeah, it's hard. It's hard.
Alright, but I mean, okay, so another example. Right triangle. What if I said this was 5 root 2? What's the measure of the sides? If this is that?
5.
5. That's it.
Oh,
45, 90. It's 5.
That's right.
Huh?
you want to say something.
Yeah. Hey, but what happens, like here's the challenge though. Here's the challenge. You need this challenge, right? You need this challenge, right? And since I'm doing it off the top of my head, alright, no, it's not gonna be wrong, but my numbers might be different. Let me see. You guys are gonna get one of these in a second. What if we said that your 45, 45, 90 was an actual, I'm trying to find one and they don't seem to have any. That's like an actual just number. Okay. No, I'm just saying if this was a whole number, right? So if this was 18. If this was 18, right? What would be the measures of these sides? Alright, so this is what you would do. If this was 18 and you were trying to find the measure of these sides, and this is an isosceles, this is a 45, 45, 90 degree triangle. What you want to do is, you want to, number one, you want to set your hypotenuse equal to what it's supposed to be, x root 2. Set it equal to x root 2. When you set it equal to x root 2, you'll find x, right? So 18 is supposed to be the x root 2 part, right, of your special right triangle. Everybody remember that? We good with that part? Yeah? Alright, so here we go. So it'll be 18 equals x the square root of 2. Because that's the rule, right? Remember, 45, 45, x root 2. Alright, that's the rule. So that's all we did. And then we solve for x. How do you solve for x? What's the first thing you do? Yes, ma'am. You gotta give me the answer? What you think it is? Okay. What do you think it is? You think it's 3? Let's see. Alright? Multiply everything by the square root of 2. Right? I mean divide everything by the square root of 2. So you're gonna get 18 times the square root of 2 equals x. Right? Remember, you can't have radicals in the denominator, so you gotta multiply the top and the bottom by root 2. Right? Everybody remember that from algebra?
Yeah.
Yeah? So that means you're gonna have 18 times the square root of 2 over 2. Alright, 18 times the square root of 2 over 2. Alright? And then that can be simplified to be what? 9 root 2. So, So the first thing you do is you set the hypotenuse equal to the square root of 2. X the square root of 2. Then you solve, right? Solve for x. And that's what we're doing. You solve for x, right? And because you got to remember, no radicals in the denominator, right? Because there are no radicals in the denominator, you just got to multiply the top and the bottom by that radical, okay? So you end up with 9 root 2 being all the other sides. 9 root 2, 9 root 2, okay? Everybody good with that? Good. All right. Let's do one more so you have it, and then tomorrow we'll do 30, 60, 90. Okay? All right. So here we go. What if I said this was a 45, 45, 90, and he was 10? What would be the measure of the sides?
Okay.
All right.
10 equals x square root 2. Then what?
Divide by 2.
Divide by 2. So divide by the square root of 2, right?
Yep. It's 10.
So you got 10 over square root of 2.
Times square root 2 on top of 11.
Times root 2, right? You gotta do the conjugate, right? And then you're gonna end up with what? 10 root 2 over 2.
Then be 5 over 2 and 5.
So 5 root 2. Is it possible that we might have a pattern there? So if that's 10, that's gonna be 5 root 2.
It's gonna be over
That's
7.
9. If that's 18, it's gonna be 9 root 2.
But I knew that already.
Half of the root, right? It's gonna be half of the actual. So it'll be half of this number times the square root of 2. But it may only have to be even numbers, right?
Yeah.
So if it's even, you might run into it like that. Okay? If it's odd, you might end up with a fraction still.
Yep.
If it's odd, you probably end up with a fraction. But if you follow these 3 steps, right? You set the hypotenuse equal to x root 2, and then you solve for x, right? And remember, you can't have a radical in the denominator, which means you're gonna have to multiply the top and the bottom by the square root of 2. Okay? Y'all good with that?
Yep.
How y'all feel about this lesson?
Good.
Más o menos, comme si, comme ça? Alright, you just need to practice a little bit more, right? Alright, so that's our lesson today. I'm going to do 30, 60, 90, 6th hour, and I'm going to send it to you guys. We'll talk about it tomorrow, but 30, 60, 90 be especially for those people that said they're not going to be here tomorrow, right? Alright, so don't forget to like and subscribe. If you have any comments or questions, comment below. MrDoTheMath out.
Comment below.